Hello and welcome. We are just getting started here as we reach the top of the hour and open up today's session. To all of you who've been waiting in the waiting room to be here, welcome. It's good to have you joining us for today's informational webinar on the upcoming program here at Carnegie Mellon University School of Computer Science. This program we're very excited about. It's called Natural Language Processing. Build cutting-edge NLP systems. We know some of you are already enrolled in the program. Others of you are here to learn more about it. So we want to assure you we're going to be touching on two key themes here as we make our way through this session. Firstly, we're going to be talking all about the course curriculum. So what can you expect to learn here? What are some of those learning outcomes? And what are you going to be doing from a curricular standpoint from week to week? The second thing we're going to be touching as we make our way through this session here is how is that learning delivered? What is the experience like? What are some of those engagement tools and other areas that are going to really help to strengthen your overall learning experience? So we're going to touch on both of those here. In just a moment, I'll be introducing today's keynote speaker. And from there, we'll learn more about Carnegie Mellon School of Computer Science's broader ecosystem that you're joining. Sort of what is the call to action? What is the pedagogical approach to learning? You'll learn more about this environment. And then from there, I'll introduce you in further detail to your course faculty, who would then take over the spotlight for today's heart, the star of the show, really that program overview, where you learn directly from the program faculty who designed this course, all about those learning components. From there, we'll step into the experiential side. You'll learn more about some of those interactive tools that you'll be engaging with throughout your time in the program. We'll talk about next steps. And then as promised, we're going to open up the floor for audience questions. So be sure to say hello in the chat. Let us know your thoughts. If you hear something that resonates, let us know. We'd love to pepper in your thoughts and questions as we go. And certainly we're going to dedicate some space here towards the end. So with that, I now have the great honor and privilege of introducing today's keynote subject matter expert and program faculty member, David Mortensen, who's here with us to tell us all about the program. We'd like to invite you in first for a quick hello here. David Mortensen is a systems scientist at the Language Technologies Institute at the School of Computer Science, Carnegie Mellon University. Professor Mortensen, would you like to jump in and say hello to the audience today?
Hello, everybody. It's wonderful to be with you, and I hope we have a good and informative discussion today.
Certainly a lot in store as we hear more from Professor Mortensen in just a moment. I'm going to hand over the spotlight. But before I do that, we did want to help set the stage for you. Again, thinking about this broader community here that you're joining at the School of Computer Science here at Carnegie Mellon University. What sets Carnegie Mellon apart? We're going to go through some of that here. But first, many of you know already, the School of Computer Science is recognized globally and as the Center for Unparalleled Research and Education in Computer Science. In part, that's due to world-class faculty, as you'll hear today, learning directly from today's course faculty. SCS offers educational opportunities to undergraduate and graduate students and executive education programs, really designed to help professionals who work in a variety of technical leadership roles to bring these concepts and these theories into a place of real-world application. So SCS is known for being at the forefront of doing just that, advancing computer science knowledge across the globe in a cross-disciplinary way, across every area, every major discipline of computer science, including artificial intelligence, computational biology, human-computer interaction, language technologies, machine learning, robotics, and software research. So you're getting that cross-disciplinary lens from world-renowned faculty. And we're also happy to announce and share that Carnegie Mellon SCS is voted #1 in artificial intelligence specialty graduate programs for computer science by US News World and Report. So if you're really looking to get that expert content from the source, this is the right place. You've certainly arrived at the right place here. As you explore these themes, you're going to gain expert advice from instructors who are world renowned in their field, but really, as they think about designing these programs, the faculty here at Carnegie Mellon University are bringing to life what they know works well for adult development, for adult learners. So really thinking about the ways in which you can make practical insights out of your knowledge. There's integrated suites of knowledge here, learning modules that leverage all of the resources available at Carnegie Mellon University School of Computer Science, and that really help you to engage in a structured way with your peers and your teaching team. So you'll have direct interaction with your course faculty, you'll have direct interaction with your peers. And we've also designed this program to be supported by learning facilitators. These are industry experts who come into this course with you and guide your day-to-day learning experience. We're going to talk more about that later on in the session. But as you think holistically about all of the various relationships here, you have yourself as a learner, you have your peers who you're learning together with and from, representing all different regions of the globe, many different industries, work experiences, and job sectors coming together to see these themes come to life, not only for yourself, but for your peers as well, giving you that expanded scope of understanding, that sort of broadened tapestry of ideas as you gain this knowledge in a deep and expanded way. In addition to those peers, you have your learning facilitators, industry experts helping to guide your day-to-day experience, your program faculty at the helm of your curriculum, and of course, this broader community here at Carnegie Mellon University, which we can leverage across various disciplines to really bring to life the very best learning experience possible. All of this is why Carnegie Mellon has such an outstanding reputation as a worldwide leader in academic research and online learning. Here's some of the upcoming programs this summer if you're interested in exploring other educational opportunities. Some of those are listed here for you today. Also, if you're a corporate client or if you'd like to come in with a group from your team, a couple of things we can offer here, some special group enrollment discounts. We also have dedicated learning facilitators. So that teaching team, we can select a dedicated learning facilitator to work with you and your team on real world business challenges that your team is facing. So a lot in store here for you. We want to make sure that your opportunity to learn is holistic and can be integrated with your professional roles as well. So who is this program designed for? Who should attend? This really is the crux of why you're here, to better understand, is this program right for me? So we're going to dive into some of these details. You'll learn a little bit more about the learning outcomes and the prerequisite knowledge requirements here in just a moment. But to give you that broad level scope here, in this program, you're going to have an opportunity to practice NLP applications via hands-on programming skills. It's a truly unique opportunity to learn in an immersive environment around a schedule that works for you and at your own pace. So this is especially suitable for technology professionals who are working full-time, software developers, data scientists, data analytics, and machine learning professionals who really want to take their skill set and their toolkit to the next level. If you do have any questions about program fit, your prerequisite knowledge, experience, your background, your industry expertise, please let us know in the question box. As I mentioned, our program advisors are here helping to support your learning, and they're going to tell you everything you need to know about getting ready for this program. So with that, I am now going to introduce your two faculty members who've co-designed this program. One of those faculty members here to tell us all about it. But firstly, we have Alan Black. Professor Black is a professor at the Language Technologies Institute at the School for Computer Science here at Carnegie Mellon University. And he really focuses on, he's a leader in speech synthesis. So he's the principal author of the Festival Speech Synthesis System, which is a free software system used worldwide by academic and industrial groups. He's the author of the FestFox voice building tools, which have been used to create speech synthesizers in more than 700 different languages. He specializes in spoken dialogue systems, language generation, code switching, and language technologies for low resource languages. You can see he received his PhD from the University of Edinburgh, holds a BS in computer science from Coventry University, and he was a research fellow at the Center for Speech Technology Research at the University of Edinburgh. He's published 300 referred papers. So certainly an expert at the helm of your curriculum, joined here by David Mortensen, who we're going to hear from today. He's a systems scientist in the Language Technologies Institute at the School of Computer Science, Carnegie Mellon University. And his work is part of CMU's School of Computer Science as in computational linguist. So he focuses on two strands: uncovering how linguistic knowledge, especially of phonology and morphology, can contribute to NLP, and using computational models to uncover linguistic knowledge and investigate linguistic hypotheses. Before coming to CMU in 2014, he was an assistant professor in the University of Pittsburgh's Department of Linguistics. He completed his graduate work at the University of California, Berkeley, where he received his PhD in linguistics for a thesis on theoretical phonology. He holds a BA in English literature with minors in linguistics and psychology from Utah State University, and attended LSA Summer Institute at Massachusetts Institute of Technology. So certainly a lot in store here for you as you think about the faculty and the research at the helm of your curriculum here. So I now have the great honor of introducing and inviting into the spotlight Professor Mortensen here to tell us more about the program overview. One quick announcement, though, we are recording today's session. Everything you see here is being recorded live, and we're going to follow up within about a day or two to give you copies of the recording as well as all of the slides. So a lot of the slides here, such as the ones I just covered, have a lot of content, a lot of information. Rest assured, you're going to be able to go back through and take a more detailed look at everything that we cover here today. Please do get those questions in the question box as Professor Mortensen makes his way through today's program overview. Thanks again for being here with us today. Over to you, Professor Mortensen.
Thank you very much. So CMU is a very interdisciplinary place, and that's something that I think you'll get from these programs. And NLP is a very interdisciplinary field, and both Alan Black and I are very interdisciplinary people, and that's something that you'll see if you enroll in the program, and as you go through it, that we're really bringing together strands from all kinds of different disciplines to better be able to model language and to be able to process language in a way that allows you to perform practical kinds of tasks and build useful technologies. Next slide. Next slide.
Okay, I have the program overview slide showcased here for us.
Okay. So from customer service chatbots to AI-enabled virtual assistants, the demand for language technologies, natural language processing in particular, is growing at a really phenomenal rate. And not only is the technology growing and maturing and becoming more widely used, there's a greater demand for people working in this area and better salaries for people who have a knowledge of NLP. In this course, it'll be a 10-week online program that's available through the executive education program at Carnegie Mellon, the School of Computer Science. And really, you'll build a fundamental understanding of NLP and its applications. So you could go online in various places and learn about specific kinds of NLP tools. But this knowledge, because NLP is moving so quickly, becomes outdated very quickly. And what we focus on here is helping you to understand the fundamental issues, the fundamental technologies, the fundamental applications that are behind NLP that will be more future-proof. So working at the intersection, interdisciplinary again, between language and mathematics, you'll learn how to use a variety of different tools and resources, including deep learning, to develop innovative NLP solutions that other people have not thought of before for everyday kinds of challenges you may face in your work. So next slide. Okay. After completing the program, you'll be able to do things like the following: to be able to use key machine learning concepts and deep learning methods to build cutting-edge NLP systems in any of the NLP domains. You'll learn to do things like lemmatization using graphical models, which is a key step in a lot of NLP tasks, but also to build language models, to make quantitative and qualitative analyses that serve as a foundation for more complex models, to utilize neural networks to do things like part of speech tagging, but also named entity recognition in English and other languages. And that is, in fact, something that we bring in this course that you might not see in other NLP courses, is a kind of multilingual component, which is one of the real growth areas within NLP, is moving beyond English to other languages. You'll learn to use word embeddings, both static word embeddings and contextual word embeddings, to represent words and their meanings in machine learning models, you also learn about things like syntax. You'll learn to train dependency parsers from tree banks and to use them to perform NLP tasks. Next slide. What does it take to succeed in this course? Well, we try to make it accessible to a wide number of people. But the basic things that are required are a strong programming knowledge of Python, because all of your exercises and so on, for the most part, will be Python programming exercises. And then a knowledge of data structures and algorithms. So basically how to understand different ways of structuring data within a computer program, and how to build algorithms that are efficient and that are correct. So if you haven't learned Python yet, we really recommend CMU's Programming with Python course. It's based on a very famous and very effective Python programming course that's taught at CMU. And this will get you up to speed to the level that you need to be at in order to complete successfully this program. So there are 10 modules in this program. Introduction to NLP, linguistic morphology, where you learn about the structure of words, very important to multilingual NLP, language models and smoothing, classifiers, deep learning for NLP, sequence labeling, lexical semantics, word embeddings, phrase structure and dependency syntax, and then sentence semantics. Next slide. In the first module, we'll give you an overview of the big issues that are involved in NLP and in the course. So you'll examine what and why NLP is what it is, its key applications and the challenges that come with it. You'll learn what is NLP and what is not NLP. So I work in two fields right now. I work in NLP and computational linguistics. And these are different. Although for historical reasons, sometimes we use computational linguistics to include both of them. So it's useful sometimes to know what constitutes NLP per se, and how we know what tasks belong properly to NLP and how they relate to one another. We also look at real-world applications of NLP. And what the ethical considerations that are involved are and the potential future uses. Ethics is actually something that's very important to us. And this is a big issue right now in NLP. What are the ethics behind data use, acquisition, and so on? What are the ethical issues behind the use of large language models like BERT or GPT-3? So we introduce this idea because we think it's important, and it's something that you will hear about and have to grapple with if you're working on NLP. You'll also learn to distinguish the different levels of linguistic structure, to view language as something you can kind of take apart and that you can model and approach at different levels of granularity. Next slide. So in the second module on linguistic morphology, then you'll explore the basic aspects of the structure of words, how words work, and how this relates to natural language processing. This is very important when you come to languages other than English that often have very complicated morphology. And so this is part of our effort to make this a natural language processing, not just for North America, but for the world. And as a teaching tool, we will use finite state transducers, a kind of graphical model. And you'll learn to use them to identify and describe the structure of words to construct machines that can recognize morphologically valid words, and then apply this knowledge to a task called lemmatization, where you take a word and return the dictionary form of the word, which is useful in a lot of what we call downstream tasks in NLP. You also learn a lot of the resources that are available right now for dealing with morphology, a lot of the data resources, and also the tools that are available to you in this area. Next slide. In Module 3, we'll cover something that's very fundamental to natural language processing, and that's the idea of language models. So you'll learn to build language models that quantitatively model what a probable sequence of words is. You learn to analyze language models in terms of probability theory. You'll learn about smoothing and methods and applications for language models. You'll learn how language models relate to the concept of embedding, which we'll pick up in a later module, and which will prove to be really crucial to our understanding of modern natural language processing technology. And you'll also learn how to evaluate language models, how to tell whether your language model is a good language model. There are a number of different ways of doing this, and this provides us a way of introducing evaluation and evaluation metrics into the course. Next slide. In the fourth module, we'll talk about classifiers. This is another fundamental notion within natural language processing. A lot of tasks that we do are actually classification tasks. They're grouping something into a set of two or more categories, or assigning two or more labels to the items. So we'll look at this mathematically, like what a classifier is, but we'll also look at it in terms of NLP tasks, like what tasks are classifiers, and very importantly, how we evaluate classifiers. How do you measure whether a classifier is a good classifier for a particular task? How do you know that? What are the metrics that you use? So it turns out these metrics are important in a whole host of other NLP tasks. And just knowing about these metrics and evaluation of classifiers can serve you very well in a lot of different areas and a lot of different domains within NLP. So you'll learn about, we'll use document classification as sort of the running example here, like assigning labels to documents. And we'll use this to motivate both simple and complex classifiers. Simple classifiers like naive Bayes that you could easily write yourself, but also more complicated classifiers like ultimately neural classifiers. And we'll also look at some specific tools and resources related to classifiers. What is already available to you in order to perform these, in order to do classification tasks. Next slide. So one of the things that really has revolutionized natural language processing in the time since I have been involved in it is deep learning. So people were using neural networks to do natural language processing, or were trying for several years before that. In fact, as far back as the 1970s and 80s. But with the advent of what is called deep learning and improved computational power of graphical processing units and so on, then deep learning has really transformed natural language processing, and we want to introduce you to this area. So you'll learn the history and significance of neural networks in the context of NLP, and you'll implement document classification tasks, sentiment classification, using neural networks. So you'll compare and contrast earlier neural approaches like perceptrons, feed-forward neural nets, with today's deep neural nets. You'll define the training process for neural nets and how you optimize trained models. And you'll implement, as I said, sentiment classification using a feed-forward neural network in this module. So you can understand the basic concrete aspects of how neural models work in NLP. But we'll also look at the kinds of tools and resources that are available to you to build very complex neural models without having to deal with all of the implementational details. So things like PyTorch or Hugging Face Transformer, we will touch on all of those. Next slide. Then we'll move to another specific kind of task. Like classification, it's a task that that is a general category in which a whole bunch of more specific NLP tasks, or to which a whole bunch of more specific NLP tasks belong. So you learn about things like part of speech tagging, which really teaches you how a sequence labeling model works. And you'll learn to use statistical and neural tools for doing part of speech tagging. But then you'll move on to something that's more practical even, and that is named entity recognition, or NER tagging, which you'll learn about from the standpoint of English, but also other languages. And you'll learn to evaluate tools and resources for tagging named entities. These are like proper nouns, basically. So if you've ever wanted to go through a text and identify all of the people and places and organizations, this is the task named entity recognition. And this is one of the things that you'll learn, and one of the very practical things that you'll learn. Next slide. In Module 7, you'll learn about lexical semantics, about modeling the meanings of words. So you'll implement computational approaches to word meanings. You'll learn about symbolic approaches to word meanings, tools like WordNet and other similar technologies, and how to use them in modern neural systems. But you also learn to quantify word meaning using patterns of distribution. And this goes along with ideas like PMI and TF-IDF, which allow you to weight the words within the context of another word in order to get more accurate representations of what a word means based on what words occur around it or its distribution. Next slide. So one important topic that we bring up at this point is that of word embeddings. So word embeddings come in different types. There are static word embeddings, which were very popular up until about 3 years ago. And then there are contextual word embeddings that are derived from large language models like BERT. And in this module, you'll learn really about both of those. So you'll learn to summarize in a non-technical justification for word embeddings and for the intrinsic and extrinsic evaluation of them. You'll learn to investigate efficiency techniques for representing word embeddings, to identify the various alternate ways of capturing word embeddings or producing them. You learn to use word embeddings to implement sentiment analysis, a kind of document classification task, and to improve those results through the proper use of this technology. But there are all sorts of resources for word embeddings that you don't want to build from scratch. And so we'll talk about the available resources that you can use off the shelf to build very sophisticated natural language processing technologies without having to implement every detail. Next slide. Syntax in Module 7, we'll see, is one of the important areas of NLP traditionally, but also today. So you'll learn how to interpret syntax, the representation of sentence and phrase structure in terms of phrase structure and dependency grammar. So you'll learn to utilize different approaches to syntax to understand how words get put together into phrases and sentences. Phrase structure and bilexical dependencies. You'll learn to define constituency, types of constituents, and the use of constituency in English language. And you'll learn to also both manually implement dependency grammars, which are even more important than constituency grammars in contemporary NLP, to generate parse trees and to automatically learn grammars from tree banks. You'll also learn to understand how dependency grammar applies to English and the components of dependency parsing, like what are the basics that it takes to parse a sentence into a dependency tree. One thing that's not on here that you'll also learn is how to train or how to use some of the existing dependency parsing tools like Stanza to get dependency relations in a lot of different languages and use them to perform semantic tasks, which is what we'll talk about in the next module. Next slide. In the last module, we'll talk about semantics of sentences. We'll learn how to construct meaning representations based on semantic roles and based on syntactic structure. So we'll be able to apply resources like FrameNet and PropBank to the task of semantic role labeling, where you label what the role of a noun phrase, the kinds of phrases that have the noun as the main word, what role they play in a sentence. Are they the one that's doing the action of the verb? Are they the one to which that action is done? And from that, you can develop a complete representation or a nearly complete representation of the meaning of a sentence. You'll learn to choose the best kind of meaning representation for a particular task. You'll also learn ways that have been developed for building up the meaning of a word recursively from the syntactic structure in a way that's relevant both to constituency grammar in the older approaches and to dependency grammar in some newer approaches. I think that's all on the modules. Thank you very much. I'll talk to you in a moment.
Thank you so much, Professor Mortensen, for being here and taking us through those module overview details. And certainly, I'm so honored to hear directly from you about this program that you've been such an integral part in helping to design. So thank you for being here to tell us all about it. You can see here on your screen, we're going to step over into more of those experiential components now. What are you going to be doing? What are some of those tactical components here in the program? And firstly, that capstone project that you're going to be working towards, it's a big tangible asset for this program. And it's a chance for you to really culminate your learning together. You're going to use a combination of what you've learned in the program, some of the tools and technologies, in order to build that realistic, complete NLP solution. So what an extraordinary opportunity for you to do that under the guidance and the helm of your course faculty and learning facilitators. You'll be able to choose a functional application among the list here: speech recognition, question answering, machine translation, and document summarization. So you can choose one of these functional applications and really build out that complete NLP solution that's realistic, applicable, and something that you can showcase as a tangible learning outcome, particularly for those of you really looking to springboard into career advancement opportunities. Certainly a big part of what we've designed this program to assist you to do is build out a portfolio, a sort of a tangible portfolio. And this is a big part of it, this capstone project here. So let's talk more about that program experience. What is the day-to-day program like? What can you expect? So we're going to touch on some of these experiential pieces and then open up for questions. So let us know what's on your mind. But this is the time where I get to tell you all about what it's like in that day-to-day component. In here at this, within this program, we follow a pedagogical approach that we call bite-sized learning. And what that looks like in real time is at the beginning of each week, a certain set of content will be released. You'll have an entire 7 days to make your way through that content. That content contains a lot of what you see here on your screen, on-demand video lectures from your 2 course faculty. There are assignments, discussion boards, components to your capstone project, knowledge checks, simulation, role play exercises, all built within that module of released activities. So you'll be able to design a schedule that works for you to make your way through that content. And you'll start by watching those on-demand videos. You can watch these around a schedule that works for you as many times as you need to, really latch onto those concepts being taught by your faculty, and then step away from that and really roll up your sleeves and engage in this immersive learning environment. Take part in these activities, these peer discussions, all aimed at helping you to really practice your learning and bring it to life before then moving on to the next set of videos. That's what we call bite-sized learning. And in that way, we're able to break down some of the barriers that we see in a traditional classroom. So in a traditional classroom, you've got a certain number of minutes to get through a certain set of content and a certain number of seats in the room. Here in this program, we're able to break down those barriers in space and in time, and making available a program that's fully immersive, where you learn as you go, around a schedule that works for you at your own pace, but also together with a cohort and a robust teaching team. So if you think of 2 key words here about this program to describe it, a big word here is interactive. We build in a lot of interactive opportunities for you to engage with your faculty, your learning facilitators, and your peers to both deepen and broaden your knowledge. So interactive is one, and the other word here is convenient. So we've built this program to flex around your schedule. You'll be able to design a schedule that works for you while keeping in step with your cohort and with your learning. You can learn on the go. So all of the information is available through a mobile device or a tablet. So for those of you who'd like to watch videos and take part in some of these activities en route or during your commute, you'll have an opportunity to do that in the program. A couple other things to note here. We start with what we call week 0. Week 0 is an entire 7 days before the learning begins, where you'll get to dive in and orient yourself with the program. We call this orientation week or week 0. You'll be able to build out your online profile, share across your details with your peers, begin getting to know your learning facilitators. You'll have all of that course information available to you, including the course policy details, the schedule, and you'll have everything you need to get oriented and to begin the program. Then you have that 10 weeks of intensive learning. So you start with week 0 where you get oriented, that 10 weeks that we described of that intensive learning together with your teaching team. And then beyond that, you have access to the program for an entire year. So you'll be able to touch back into these themes, watch the videos, continue engaging with your colleagues and networking and building and creating together for the remainder of the calendar year. This course is really designed to, again, help you not only to gain these tools, but gain the confidence to apply them and the acumen to apply them as well. You're going to be building out your professional network, gaining peers and colleagues from across the globe, expanding that toolkit. And another big return on your investment in time and energy here is a chance to earn a credential from Carnegie Mellon University School of Computer Science. Many of you know this program does culminate an opportunity for you to earn a certificate here. This is a formal credential that really allows you to showcase your learning, formalize your training. And again, if you're looking to springboard into those career advancement opportunities, certainly having a certificate here is going to go a long way in helping you to do just that. So we describe how this program is reciprocal. You're really contributing and gaining. There's a lot of opportunity for you to individualize your learning as you work towards that certificate. If you discover a niche area of interest, a niche curiosity, and you want to go and dive into more detail, you can come into office hours with your learning facilitators, gain those additional resources, start discussion threads with your peers, and really engage in that reciprocity of learning. So this is not what we call a massive open online course where you just simply gain new tools and are asked to go out and apply them. This is a highly specialized program that's going to get you prepared for the job market, get you prepared to apply these tools and broaden that professional network and certify and formalize your training. So certainly a unique opportunity to extend beyond the reach of what's possible in a traditional classroom environment and earn and gain these skills so necessary moving ahead with the landscape of this industry and where things are going. So there's never been a better time to start than now. We hope that you'll join us. But if you open your chat box, you're going to see right there in the chat box, there is a link and an email address. And we invite you to take a look at that link there in the chat. This is where I have the great honor and privilege of introducing our program advisors. Many of you have been meeting and talking to them in the background here through the chat in the question box. But our advisors are the course foremost experts when it comes to all of the logistical information for this program. So course start dates, additional runs of the program, any information about course policy. How do I earn that certificate of completion? What's the evaluative criteria for the program? They can help you with those details. And of course, the registration and enrollment process, how do I register? How do I get my application materials together on time? Exploring some of those financial options that we talked about earlier. We have flexible and transparent payment options, special group enrollment pricing. Your advisors can walk you through all of those details. So how do you get connected with a program advisor? We've made that easy and simple simply by clicking on the link right there in your chat. It'll take you over to the course website where you will have an opportunity to use an app called Calendly that allows you to select an appointment that works in your time zone. So you'll be able to go right to the website, grab a slot that works for you and book that appointment. From there, you can speak with your program advisor about any questions as you prepare to begin this program and complete that application. Right there on the website, you'll also be able to download the full course brochure that gives you everything we talked about here today and more. It is a comprehensive end-to-end scope about this program, and a beautifully designed brochure will help you download that and take a look. And of course, right there on the website, you can also begin the application as well. If you prefer to connect with us by email, that email address is right there in the chat box, cmuscs@emeritus.org. Simply let us know by email what you have on your mind, or if you need a connection with an advisor, and we'll get you linked up. It's always good to review here towards the end of our session what those prerequisite requirements are here. So really strong programming abilities in Python. So we do have courses here at Carnegie Mellon. One in particular that you might want to take a look at here. There is a programming in Python course. I'll just highlight that for you here coming up this summer. We also, something to mention that we didn't note here as part of our program prerequisite slide, we do have self-assessments in the program. So if you go ahead and get started here in this program, during week 0 orientation week, there will be some self-assessments designed to help you to better understand if you have the prerequisite knowledge required in order to be successful in this program. So there's going to be a chance for you to take a look at that as well here. So with that, I'm going to tee up our final slide here one more time. Grab that link there out of your chat. If you haven't done so already, go on over to the course website and get connected with an advisor for next steps. Since we've reached the end of our questions, I think what I'd like to do here is invite our professor back in for any final words of wisdom, comments, advice, anything else you'd like to share here. Professor Mortensen, as we close out the session, anything you'd like to leave us with?
Yes. So NLP is incredibly an incredibly exciting field to be involved in right now. It's changing and developing so quickly, and it touches on so many different aspects of our lives, but also aspects of computer science and the other sciences and other fields of human endeavor. So it's really, in a way, at the forefront of a lot of areas of artificial intelligence right now. And this course is a chance to get involved in that. And so I really urge you, whatever your background is, as long as you have this basic the basic prerequisites that we've talked about here, good Python skills, good data structures and algorithm skills, basic fundamental math skills, then this is a great course for you to enter, a great program by which you can enter this exciting field and be able to apply aspects of this field in your work, whatever it might be.
Absolutely. There has never been a better time to join. Thank you so much, Professor Mortensen, for putting this course together and for being here with us to tell us all about it. Very excited to see this program launching, and want to thank you again for being here today to share more about it. From those of you who've joined in from across the globe, thank you as well for being here. What an honor to learn shoulder to shoulder with each and every one of you from across the globe. We hope you'll join us back in the program. Please do grab that link out of the chat before you leave the session here today. But thank you again for joining. For now, we will leave you with a heartfelt good morning, good afternoon, good evening, and good day to all of you from around the globe. Thanks again for joining, and we hope to see you again soon. Bye-bye.